Okay, so this is a video tutorial on pressure, on how to solve pressure problems involving hydraulics, okay? So let's go back to what we studied. First of all, what do we know about pressure? Okay, from the definition of pressure, we know that pressure is force exerted over a certain area. And from that definition, you can already get the formula of pressure. Force over or divided by area, because the definition says pressure is force exerted over a certain amount, a certain area. Okay, so it's force over or divided by area. Okay, and force is measured in newtons and area is measured in meters squared, okay, or centimeters squared. Okay, remember area is a square, okay, because you measure it by length times width, okay? Or if it's a circle, you measure it as pi r squared, not 2 pi r. 2 pi r is circumference, okay? So what else do we know about pressure? Okay, we know that in a simple hydraulic system, such as this one, okay, the pressure of piston 1 is equal to the pressure of piston 2, okay? So in this drawing, you see a simple hydraulic system. A simple hydraulic system has two pistons, 1, 2, okay? So I'll just label this as piston 1 and piston 2, okay? So what do we know? The pressure of piston 1 is equal to the pressure of piston 2. Okay, so P1 is equal to P2. So let's put together everything we know. We know the formula for pressure. We know that in a simple hydraulic system, the pressure of piston 1 is equal to the pressure of piston 2. Okay, so let's put in our the formulas. So we know that piston 1, okay, in order to solve for the pressure of piston 1, we need to divide the force applied of piston 1 by the area of piston 1. That's the reason we have I put the number 1 here, so that you know that we are solving for pressure of piston number 1, okay? And for piston 2, you divide the force of piston 2 divided by the area of piston 2. Okay, so force divided by area. And once you have that already, all you need to do is to substitute the values, what is given. Okay, so for piston number 1, do you know what force is? Yes. Okay, force is 100 newtons. So plug that in. 100 newtons. Do we know the area? Yes. Area of piston 1 is 5 cm squared. Okay? And this is equal to the pressure of piston 2. Now, do we know the force? Okay, the force produced is 400 newtons. Okay, so 400 newtons divided by area of piston 2. Do we know what the area of piston 2 is? No. Okay, we do not know the area of piston 2. It is not given. So assign a variable. For me, I just prefer to use x. Okay? So now you have an equation that you can solve for already. Okay? You have an equation that you can solve for already. And how do you solve this? You cross multiply. Okay? You cross multiply. So you multiply this two. Okay? And you end up with 100 Newton x. Always include the units, okay? Which is equal to, multiply these two values. Okay? And what do you have? 400 times 5 is 2,000 Newton centimeter squared. So why isn't it Newton over centimeter squared like this one? Because you multiplied it. Remember this. If you multiply the number, you also multiply the unit. Okay? Multiply the number, multiply the unit. If I'm dividing it, if I divide this, I need to divide the units as well. That's why if I divide this, the answer would be 20 newtons over centimeter squared. Okay? But this one I'm multiplying. So it's 2,000 newtons centimeter squared. Okay? So what do I do next? Isolate the variable. Okay? We want x to be by itself. So since this is a multiplication operation, in order to remove 100 newtons, I need to divide this by 100 newtons so that x will be left behind. So divided by 100 newtons. And since I divided the left side by 100 newtons, I have to be fair and I have to divide the right side by 100 newtons also. Divided by 100 newtons. Okay? Always include the unit. So, 100 newton divided by 100 newton, I can just cancel this because it's equal to 1. So I'm left with x is equal to, what can I cancel from this side of the equation? I can cancel the unit newton because newton over newton is equal to 1. So you can cancel it. I can also cancel the zeros, which makes the division easier. So what do I have left? 20 centimeters squared. Okay. So 20 centimeters squared is equal to x. So that means the area, okay, going back, the area of piston 2 is 20 centimeters squared. Okay. So, how do you know if your calculations are correct? Okay. Go back to your equation. Okay, go back to this equation and substitute your value for x. Okay, so this one you substitute for x. Okay, so let's do it over at this side. So now you have 100 newtons divided by 5 centimeters squared is equal to 400 newtons divided by, what is x? 20 centimeters squared. Okay, so 100 divided by 5 is 20. And what is the unit? Since you divided the number, you also need to divide the unit. So this is Newton over centimeter squared is equal to, okay, as I said, you can cancel 0, so you're left with 40 divided by 2, which gives you 20. What is the unit? Newton over centimeter squared. Are they the same? Of course, 20 is equal to 20. So your equation is balanced. That means your answer is correct. Okay? Tan ta ta tan! Yay! Happy face. So if you have any questions, you can ask me through Facebook. Just send me a message. Okay. Now, I uploaded some moments worksheets. Okay. If you cannot see it clearly in Facebook, then you can go look in year9science.weebly.com and you can download it. Okay. But for the meantime, try and solve this. Okay. Simple piston. Okay. You have piston here attached by a pipe. Okay. And you have another piston here. Okay. So the master piston okay, exerts piston 1, this is piston 1, exerts a force of 25 newtons, okay? And the area is 2 cm squared, okay? And piston number 2, okay, has an area of, let's put it at 3 cm squared, okay? So solve for force 2, okay? What is force 2? So if you know the answer, okay, post it online and see if everybody gets the same answer, okay? This is Mrs. Ness signing out. Bye-bye.